So at this point, I would like to show you now how we can get all the fruits of our hard labor from Blender over into Fusion. But before we do this, I just wanted to repeat kind of like one philosophy. Last class, I made jokingly the comment that actually we should replace the term CAD with the term maybe like DDT, digital design tools. And the main reason behind that is that traditionally today people still think about CAD mainly as a software environment that, for example, an engineer uses, so which is physically very correct and precise. And to a certain degree, that's valid. However, for the creative process, it's not necessarily always the best idea to do CAD. For example, because traditional CAD is actually sometimes very slow, we still employ a lot of sketching today because we can draw certain views faster than we can model it. However, in today's time, there are so many different digital tools we could use to explore ideas that thinking about sketching and traditional CAD, in my opinion, is like putting yourself handcuffs around your creativity. So one of the main reasons why, for example, I selected this furniture exercise was obviously to teach you how object-based and mesh modeling and sub-D modeling in Blender works. But the main idea or goal behind that was more to illustrate a certain process. So you know by right now that actually Blender, we deal with objects, we don't deal with sketches. But because they are objects, we can rotate around, we can see the values, and because we have modifiers, we can also create geometry interactions between the different objects or meshes. So essentially, that's also the main reason why I prefer using and teaching Blender instead of, for example, Modo or Maya, is the modifier tree is very similar to a feature tree in SolidWorks. Basically, you have input geometry, and then step by step we adjust the geometry. And in Fusion, it is the timeline. So modifiers in Blender are like features in the timeline in Fusion. And the nice thing about Fusion is we can take, for example, the wood geometry, or we can take the upholstered geometry, bring it over, and then convert them into industrial strength NURBS surfaces, so that, for example, for the joinery and drill holes, then in Fusion we can use Fusion's own features or modifiers. So basically what this means is we can use Blender to quickly explore ideas because it's object-based and we are not limited by how we have to set up a design. But then once that explorative phase is done, we can get everything over to Fusion, continue working with the geometry instead of having to restart from scratch, and finish then the design with CAD data, which we can then send to a shop to create a prototype, or which could be used for manufacturing. So let me show you actually how that works. As you can see, I hid the layer with the upholstery on it because I would like to start working with the front leg. So I have this one selected, and that is on this layer, and let's take a look, and there is, interesting, there's a Boolean modifier problem. So I probably didn't overbuild correctly enough, and yes, I didn't. You see the lower side, the left side, and the top side, they're all perfect, but here at the end you see the face is flush with the wood, and that is not very good. I want to overbuild, so here this edge has to stick over just a little bit. Okay, perfect. Good. So I want to bring the geometry over so I could recreate the individual features, for example, the joinery, then the drill holes, and for example, the cutting at the bottom. So essentially, this part I would like to bring over. And I have all these individual modifiers here right now. And I'm dealing actually just with plain square wood geometry. So the process I can use when everything I need to get over does not have to be later softened or smooth. So we're not going to use the T-spline system. I can do the following. So I will, for example, select all those three wood objects. Then I go to File, Export, Wavefront. And for example, on the desktop, I will call those maybe wood legs backrest. Give it a good name. The forward can be -x, z instead of y you want to set to, up instead of y you want to set to z. Selection only, that actually exports only the objects we have selected, and apply modifier have turned off. Perfect. Then click export. Then let's go to Fusion. Before we do anything, let's go to preferences. So in preferences, under general, make sure you have your Z set up to be your orientation instead of Y. Under preview, also the mesh workspace, sign me up. Okay, that's fine. And then apply. Okay. And in case you had Y before, instead of Z, you want to make a new design. Also, you want to see the timeline. So in case everything looks more like this, right mouse button click in the browser on the top component, capture design history. Perfect. So what we will do now is we will load the geometry which we just exported, and then we use Fusion's internal function to convert the polygon-based flat faces into NURBS-based faces and then create the solids of it. To do this, we can go to create mesh, or we can actually take a shortcut, simply select create base feature. You see in the timeline it creates a base feature. Think about the base feature as a container into which we can load static geometry. Then go to insert mesh. Here is my wood legs and backrest. Open. I am in millimeters, that's fine, but here make sure that the unit type is meter, because Blender internally actually works in full units. So when we work with the metric system, 1 meter is the base unit. So meters as import unit type. Click OK. And if we zoom out a little bit, shift middle mouse button, you can see that these legs were positioned a little bit to the left along the y-axis. If we quickly check with Blender, okay, I switched actually the axes, so this is X and Y, but you see it got exactly positioned the way how they are in Blender. Perfect. Good. So step 2. We imported this polygon mesh. You see here in the base feature there's nothing we can select because now we have to convert it, modify mesh to Brep, and convert those into NURBS geometry. Click OK. There. Let's go to bodies. And the problem we have here right now is we have those 3 objects and all their faces inside one body, which is not good. So to fix this, we go to patch. Now model is everything with solids, patch is everything with surfaces. We can go to modify, unstitch, and for example have, if nothing is selected, click this object, so it should be all blue, and go to OK. Now everything you see got unstitched, so basically all these faces are now separate. And what I can do now is I select modify and then drag, left mouse button click, drag from the right to the left. That selects everything that's under it. And shift middle mouse button, and you see this face is highlighted red because there's an open edge. Click on that face and then all 6 faces are selected. Click OK, and you see there we have a new body. Perfect. One more time. Now here we have to be careful, this face, and then left mouse button and drag to the left, click OK, hide this one, and then modify this one. OK, perfect. Now we have, as you can see, the same wood parts, but the raw parts. So how do we do now the joinery? And I'll show you 2 ways how we can do those. One way will be to import the objects we created in Blender, so we get exactly one-to-one the same joinery, so we don't have to do any other work. And the other approach would be to recreate what we need for the joinery inside Fusion. And then you can see which one has advantage and disadvantage. We will finish this project rather with a, I don't want to say crude way, but not necessarily a way that where we created everything from scratch in Fusion, but we simply reused everything from Blender or any program that can create polygon geometry, and then we used the solid modeling tools in Fusion to finish the design. Okay, so let's go back to Blender, and I will go to the layer where I have my different geometry for the Boolean operation, and I will start with the backrest and the back leg. So here is this one face that trims, for example, the backrest at the bottom, and there are the 2 volumes that cut the grooves or the space for the joinery. So those 2 selected, I can press spacebar, type in export obj, or go to file, export obj, and now for example I will give this one a better name, backrest trim selection, don't apply modifiers, we'll leave everything, export. Let's go to Fusion, and we can we edit this one? Yes, we can. And so I went back to this feature, and then can we insert anything here anymore? I was just curious if this works. Yes, insert mesh. So then here's my backrest trim, open, and we say meter, and you see they perfectly snap into position. So no repositioning. That's pretty awesome. Click OK, and we can, for example, say finish mesh. And now it's up to you if we want to make a new base feature or if we keep it in the same base feature. I would simply, for the sake of simplicity, work on the same base feature here, and you will see later why. Okay, modify mesh to Brep. Let's Brep everything, and then again there we have some problems. Unstitch, deselect, change select. This one I want to move out. Okay, those are hide. I hide. One more time, unstitch, and here, here, here. The reason why I unstitch with the chain select off is simply, you see, I can just select certain faces I would like to move out to separate. Click OK, and then this is my leftover. I can one time click stitch, so it's a solid, and then I select all those, stitch, and there we are. Perfect. Ding, ding, ding. Good. So the main function of base feature is also, as I said, it's just a container where we can dump geometry into, and we can also perform direct modeling. So think about the base feature like when we go into edit mode in Blender, everything we do is final. So when I start my cutting for the joinery, I don't want that necessarily to be final, because it could always happen that something might change. So I click Finish Base Feature, and now let me show you how the timeline works more, and how or where the different functions from Blender, Mirror, Boolean are inside Fusion. So say hello to the combine command. The combine command is actually the Boolean operation in Blender. And for example, let's work on the backrest first. So Boolean combine. So we can click on it. So you have to be actually in model, not in patch mode. Then go to target. Target is the piece we would like to cut something from. The tool body is obviously the piece we will use to cut something with. So this volume we will remove, as you can see, from the blue selected object. Operation cut automatically is selected. We don't want to union join them. We want difference cut it. Click OK. Perfect. And there you see now this actually is cut. Let's do the reverse. This object needs this volume be removed, so we have the slot for the joinery. There. Perfect. Okay, great. Now I have this one left. This was actually the object to cut this later. So I can make use of it. However, this does not work with the combine, because this is a surface, this is not a solid. Now in Blender we can use a volume or a surface with the Boolean operation. Then it switches between Boolean union or subtraction or surface trimming. But here we have something called a split body. So we can select split body. This is my body to split. I would like to select this plane, and then with red it gives you a preview of the axes, which will be used kind of like a knife to cut through. Click OK, and everything looks the same, but you see now there is some extra object. So this object we can select, right mouse button click in the browser. Don't select delete, because that actually deletes in the beginning of time the entry of this whole object. We just would like to remove what's highlighted in blue. Remove, and there it's gone. Perfect. Now this has one tiny inaccuracy, and you see actually there's a small step. And I had this on purpose because Blender, the modifier, was a little bit picky about when the cutting surface would be at the same level height-wise as, for example, this surface. So that was not really super ideal. So, however, because we are now in CAD, which is sometimes a little bit more precise or forgiving in certain situations, what we can do is this cut command. Here I can double click or press escape, right mouse button click, and then you can select edit feature. So I will not use actually the surface I used to cut. I can, for example, say this body, split along its own face. So that's the bottom. So think about now there's a small face, and it obviously does not cut completely through the object, or size-wise it doesn't penetrate it. But the nice thing about the split command, because this is a planar face, it extends the cutting. So now you see we can use that one to simply slice it. So the remove command flips out, we get an error message. That's fine, because we try to remove an object that doesn't exist anymore. So now we can select this one and maybe this one, and then remove both. Perfect. There, see? Nice. Perfectly fits in. Okay, so that wasn't too bad. So let's take a look at the front leg. So how did I do the joinery? So this one will be flat. So I want to cut in here. Okay, so let me show you now how we can, via not necessarily direct modeling, but via modeling commands, actually cut into the object. So in Blender, if I have this face, I can actually extrude it out. So now we can do the same with the extrude command. You can select a face and extrude it. Easy peasy. Okay. But if I want to extrude just half of this face, I need to have an edge that, for example, slices this face into two. So in Blender, we would go in with the knife command and cut this face along this edge to this edge. That works very easy in polygon modeling. In parametric solid modeler, not really the same way, but what we simply have to do is create a sketch. So we can use the sketch to create new areas, which then we can use for the operation. So to make a new sketch, we can go create sketch, click, for example, on this face. You see the grid updates based on the face. Click on this one. Perfect. And then we can use the line tool. And the trick is now, you see when the mouse gets close to a midpoint, it actually snaps to the midpoint. And if I click and then go to there and click, you see I created a line, and the line has actually two constraints. And that basically means with this triangle, if you go to the right side, the midpoint. So this line is permanently glued to be always on the midpoint of this edge. Okay, so let's leave it at this for the moment. But essentially, you see now we have two faces. Perfect. So let's select this line, 82.55. That is the length. We can go extrude, select this face, and then extrude, for example, 82.55 out. And you see the extrude command then has a join operation, so it works similar like combine. And if we turn the value into negative, there you see that actually now it cuts into the object, and you see the operation switched to cut. Click OK, and we ended with this one here. So not ideal. Let's see how we can fix this. Let's double click. Can we taper it? No, so this tapering is not really ideal. Okay, so what's the problem? Well, this is actually one of the situations where now the software probably gets confused with slicing something exactly along the face of the object. And again, that is why, like in Blender or in Alias, always say you need best ideally overbuild to help the software. So you see, it's not only in Blender with the Boolean modifier where we can run into issues. The same can run actually also, or happen also with a hind package. It's simply a tricky math situation. So what can we do to help the software? Well, this is actually very easy. So we could, as a hack, bad, but works, simply extrude this silly face out and then we are done. Perfect. But that's kind of really dirty. That's not really good. So double click on the sketch and simply what we will do with the line command, we overbuild something. There, and it's connected. Perfect. So I can press D or go to, where's dimensions? There, sketch dimension, and say you, please maybe just 2 millimeters distance, this line to this line, drag it out, left click 2 millimeters. So I make this a little bit smaller, 2 millimeters. Okay. Another cool nifty trick with the dimensions for those who are new to Fusion. You see here and here I entered the values by hand. I can also double click and then I get back into the edit mode, click this dimension and you see it copies the value or the name of the dimension. Press enter and it says the function is currently 2. There, there, there. And then if we say here 3, they all update. So these are driven dimensions. So these dimensions are getting their information from this dimension and then they adjust the geometry. Sorry, the sketch. Perfect. Okay. Click stop sketch. But then we still have this undesirable result. So how do we fix it? Well, the thing is, if we double click onto this feature, it shows you that while I added this new sketch element, it still only uses this internal rectangle we had first. So we have profile 1 selected. If we just then click on this one, we have 2 selected. And now you see the red box is much bigger. It's overbuilt. In case you can't select it, simply press the X and say 1 and 2. But be careful, you really select the correct things there. And then what was the depth? 82.55 minus, okay, there. Perfect. Cool. Pretty nice. But you see, it was a little bit of extra work we needed to do. And let's say we still have this leg over or left to do. So how we do this? I could, for example, in this case say, no, this is my target object. So with a Boolean combine, this is my tool. I would like this one to cut out, and you see there we run into an issue again. And click OK and shoot. First, this is still an issue and our other leg part is gone. So when we double click the combine, there is a nifty function here, keep tools. If you click keep tools, that basically means it does this calculation, but then it keeps the element. Perfect. Okay, so we can hide this so it's a little bit easier, and then we can not do this. Maybe on the smaller face. Yeah. No, come on. Cut this out. Good. So there, I cleaned up the design this way. Perfect. Okay, nice. So now that we have those those 3 elements, left, right, and the backrest. So maybe at this point, let me show you the mirror modifier. the mirror modifier, we can select different objects, bodies, 1, 2, 3. So in Blender I say object, and in Fusion it's called a body. Then we have to select the plane, and then also here in Origin we have the planes as well. So for example this one, which is the YZ plane, click OK, and then you see it mirrored it over. Now the advantage of the way how features or modifiers work in Fusion is actually, you see, it is step by step. So the mirror modifier really creates individual objects, while in Blender the mirror modifier inside one object creates more mesh bodies, which can have its own advantage. But I just wanted to point this out. It works a little bit different. Okay, good. So let's take a look at the wood planks there. Maybe we select this one. So export obj wood plank front modifiers off. Okay. Then let's go back to Fusion and double click this feature here, create insert wood plank front, open meter, and okay, and then finish, and we can go to the Brep and say modify mesh U to there. Let's rotate around, and where's the part? It's there. Okay. There are some triangles, which sometimes happens and sometimes it doesn't. So let's see if I can fix those. Perfect. Great. So you see there is a merge command there and there. Merge these two faces, and then the others got fixed as well. Sometimes the code in Fusion can get confused and think that this was actually not a planar face, so that from a side all these points are on one plane, and then it triangulates the geometry. But you see with the merge command we can fix that. Great. So array modifier. Fusion has exactly the same. It's under create pattern, rectangular pattern. Okay, so we have to select an object, that is this one, and then we have to select a direction. Now with the direction in Blender, the rotation of the object gives you the direction itself, and then we can say go along X, Y, and Z individually. So if I go quickly back, there you see there are our directions X, Y, and Z, and because the object is rotated, you see it actually, it uses just the Y, but it uses the Y of local space. So how do we do local space in Fusion? Because we don't have local space, but because this is a flat wood plank or flat object, we have these edges. We can select this edge and then drag like local space the wood plank out. Perfect. How many do we have? We have 4. Quickly wanted to measure the distance between those two parts. So I'm going to do it quickly this way, and snap and snap, click, click, and delete. There is a line, and this line measured is how much? So 0.7 inch. Okay, so and extend the spacing. I think, where do we put the spacing in there? 0.7 inch. Or that's actually not it. Okay, sometimes I get confused about how actually the spacing there works. Yeah, okay. You see the array modifier uses a different settings. So now I have a maximum distance. So over 400 millimeters, I have 4 planks, and with the spacing, so 100. So it's basically, you see from this point to this point, that's now 100. So there's a check mark. You see we can actually do, that's pretty cool actually. We can do an array and then somewhere in between even clip parts out. So how long is one part? We can actually do the measuring easily here. Cancel. So what's this? 88.9. So rectangular pattern. U down 4 there. So 88.9 millimeters. You see now they're actually perfectly touching each other. Plus, I think this will work. 0.7 inch. Yeah, there. Perfect. Pretty cool. Also here you see you can work with different dimensions. That's actually really nice. Click OK. We're good. Perfect. So totally recreated that part. Now I can either make a copy of this one, or I could go to here and say, where is my array modifier? It starts there. Good. So spacebar, export wood plank front 2. Go to Fusion here, quickly import it, and there, ching, ching, okay, and then, oh, why did you create this one too there? And this is actually an insert at the end. That's not what I wanted. Double click or edit. Sometimes the things can be a little bit finicky. So insert one more time. Okay, now I put it to the correct feature. Okay, finish, base feature, hue, convert. See, in this case here, Fusion was nice. So everything worked out perfect. I don't need to adjust the mesh. Okay, these things I can hide. And there's another cool thing I would like to show you now. So this array modifier or feature or linear pattern feature uses a certain formula for the distance. And you see this one is D26. We also, under change parameters, can find D26. There, you see, D26. So let's say array spacing is the name. We can override it. So this is just the name. Okay. Then we go to here, object, direction this edge, and we go spacing, I think, was it 4 or so? 4. And then for the distance, that would then be array space. And that's the downside of Fusion. You have to be careful about the naming. You see it's red, it doesn't find it. So we have to enter the correct name and spelling. It doesn't find it for us. But so that's the reason why you should select good names, short at best. But then you see this way, this works. No, the really awesome thing is if I would go ahead and adjust this one here, let's say 2. See, the other one updates. So welcome to parametric modeling. Everything will be formula-based driven. So it's driven design. Okay, nice. So let me quickly finish the backrest. That piece is up there. Perfect. So they're the same. And here we say backrest. So you see, I like working object by object instead of exporting everything at once, which might make it easier, but exporting a part just takes you 5 seconds, and then I can always go back to the same feature that holds all my imported mesh, and this way keep my design nice and clean in Fusion. Okay, go back. Also, in case you want this one to be in the toolbar, when you go with your mouse to a function, click this one and it moves it up. Perfect. Click this, click OK. And we have to fix this. So merge, number 1. And you see, it fixed some other faces for us. Right click, drag up, there, fixed. Okay, this is the last one we have to do, you and you there. So the nice thing, because we are currently in a base feature and this is direct modeling, so it has no history, all these commands to clean up will later not show up inside my design. So I'm kind of mixing a parametric, non-parametric approach in working, which is also again similar to the way how I work in Blender when I do concept models. The mesh modeling, that is actually kind of like the feature free, where I can sculpt, and then with the modifiers I define my design. Let's go back to Fusion, and then there we have to do the same pattern there, you 4, and then the distance is array spacing. Oh, at 5. Good. Perfecto. Okay. Good. So the step that's basically left is how to recreate, for example, all the joinery for how we connect the wood planks onto the wood, and for example the drill holes or dowels, whatever we decide to do. And what we will select is basically maybe a dowel process, but at the same time, in addition, I would like to show you also how the hole tool works. So for example, when we go to create, there is the hole tool, which is a pretty nice and amazing tool, because you can simply select a flat surface, and then you can specify the depth, for example, and the diameter, how far you want to drill, and then you slide this around. But the problem is, well, there is nothing to snap onto. Okay, so, but I want my holes perfectly at the center of those faces, but on this face. Okay, so let's go back actually to here time-wise. So this is actually the part, and when we create holes onto this one, and then later we will do an array, we will array an object with the holes. So basically the same like we have it here in Blender. We bevel it, we array it, then we boolean it, or we can do it this way. So there you see it's simple one task, and then we do the array. Okay, so how do we get the information for the positions for the holes? So let's say we want later to drill something in. So we have to make a sketch again on one of the faces, and I will select here this front face. It actually looks like it was selecting the other face there. Let's see, which one did it select? It selected the back face. Stop. Let's delete this one. Let's try this one more time. Interesting. I don't know why it's selecting the other face. Okay, not a big deal. So inside the sketch, I would like to have this line and this line. So the command to get this geometry usable is actually called project. So I will go to sketch, project, and then project this line and this line from the geometry into my sketch. And when I hide all the objects, then you see there is now this line. So this line basically tells me left and right. Okay, perfect. So now I can, for example, create another line. For example, here from the midpoint, and just do it straight over till there. Perfect. Okay. So on this point, I can, for example, on this line, I can create maybe if I want another line, or to make it easier, I can make a point. See this point? Well, think about it like the empty in Blender. The point in Fusion, however, is just two-dimensional because it's inside a 2D sketch. But what's this one useful for? So what I can do now is this point I snapped. You see there's a coincident constraint which makes sure that this point I can only move on this line. I can't move it up. Because this point is on this line, it is horizontally always at the midpoint of this bigger yellow rectangle. But now I need to figure out the way where is the midpoint here. So when I press D, you see I can select this edge or this edge. So not really super ideal. So this thing was kind of garbage. But I will redo it. I will simply do it this way. From this midpoint to, and this is important, that actually you see there's a white, a blue rectangle in the corner. I created a new line, and then here you see this constraint is actually perpendicular, so this line is horizontal. And I can do the same from there to there. There it is now. Zoom in, it doesn't snap to the grid, but just a line. There, perfect. Good. So now because this is a shorter line, I can go ahead and go to the point tool and say snap this one onto the line and the midpoint. Perfect. Cool. See? Very easy. So why did I do this? So I want to hide this one and I want to hide this one, and these two I hide because now I can, for example, make a hole at, you see I can snap actually to this point there. Can, for example, cut through. Flip direction and it goes the other way. Okay, I need to figure out actually why I wasn't able to make the sketch on the other side, because you see the drilling actually goes to the left, so that's not really super ideal. But it essentially, that's the way how, for example, the drill command works. And in case there would be wood behind, then it would not only drill through the main plank, but also whatever is behind. And we can have a simple hole, counterbore, countersink. So let's say in case we want to use a wood screw or something. So you see it cuts the cone for us. But in our design, we will use wooden dowels. So how can we do that? So there's a little thing we need to change inside our design in Blender. So let's get over. And where are my wooden dowels? There's number one, there's the other one. Okay, good. So what's the problem with my geometry I have? Well, the thing is, we created this actually based on a simple polygon shape. And you see this is faceted. This looks like a cylinder, but in reality it's very faceted. So this is actually not really super ideal. And we have to change this a little bit. I will make a copy, move this one to here, and for this copy turn everything off in terms of Boolean, so you will see what I will do. Let me switch to metric. So this is a 5 and 5 millimeter wooden dowel. Okay, so we have to recreate a geometry which we can then, when we send it over to Fusion, turn into a nice and smooth cylinder again. So cursor to selected, so it is at the center. This is 5 millimeters. Shift A, and then we will create a circle, and toolbar vertices maybe 6, maybe 12 we can use. Okay, radius 2.5 millimeters. Okay, rotation, in my case, X 90. Okay, so I created, as you can see, a new ring with more points, but less points than this one. So why did I do this? Well, let me create one more time the same, but this time here I will use maybe just 8 and 90. So when we actually add the subdivision modifier, pay attention to what happens to dimensions. Subdivision modifier, see the dimensions got smaller. And when I increase the value, it gets even smaller. Okay, so that makes sense because the smoothing actually makes everything smaller and smaller and smaller. So this is the only situation where I will give you an advice to work with a high subdivision level. So here now we can set this dimension to 5 and 5 millimeters, and you see there's a small scale factor, and the scale factor we will apply now. Okay, and when we hide this, you see this object got a little bit bigger. But when we add the subdivision modifier, we get exactly a 5. And this one we will delete. We don't need it. This one will work really well. So why did I do this? Well, I would like to introduce you to 2 different types of circles or cylindrical shapes. We can have a mathematically perfect described cylinder, so a center, and then like with a compass via math we can describe how the surface rotates around the center point. Or we have, for example, certain points, and then a surface is woven like in between. But the thing is, this looks like a nice circle. It is, however, not consistently a circle with 2.5 millimeter radius. This is more a sculpted circle. There's nothing wrong with it. It's just simply 2 different types. And this is the one as a designer you can work a lot with because we have more sculpting abilities with it. So Why did I actually create the simplified object? So the trick is now this geometry, and I will turn this back on. I'm snapping to the vertices. I will bring this back to there and snap it, and then I press E, and then in my case Y, hold Control and snap it to the end. Okay. So I will move this one also a tick away, so you still see what we have. Okay, goody. So essentially, again, this is a very coarse polygon model, and with the subdivision surface modifier, we smooth it. And I mentioned actually in Fusion we have something called T-splines. That works like the subdivision surface modifier, but it only has no subdivision, or the surface is perfect, so there are no different steps. Which is why in this case we went to view 6, so we have a maximum smoothness, so this is closer to T-splines, and we can see the dimension. Okay, so I would like to turn this back into a cylinder. So here at the end I press F to fill it, and then you will see this. What's going on? Well, it's because this is a face and this is closed, so the subdivision surface modifier will try to smooth everything. But when you go to the mean crease and we set this to 1, you see we sharpen that edge. There, perfect. Let's go back to there. A to deselect everything, select this, and then B and F, and we capped it. Okay, great, isn't it? Yeah, I think so. Good, so maybe we can call this one subd dowel, and here we call this one subd dowel mesh. So why did I do this? Well, you remember there's a difference between making a duplicate and making a linked duplicate. All those, actually, as you can see, they use the wooden dowel. So what I can do now is say, well, instead of using wooden dowel, like this one, let's call this one actually wooden dowel master. We simply tell it, hey, just select the subd dowel. There, see? And we do the same here, subd, and select this one, subd, and this one, subd, perfect. So this is now the object actually which we would like to bring over, because this is the part that, as you can see, sits in there. Okay, so let me show you now how this works. So this part, it actually has these modifiers turned on as all union, so I get all these 4. And I will actually, I will keep it this way. Otherwise I could also say, well, export all these 4 objects. That works as well. But in this case here, I can keep all this turned on, or to be consistent, let's do it this way. Okay, good. So spacebar, export, obj, modifiers not applied, and then we call this one wooden dowel front. Okay. Then let's go to Fusion. And at this point now, I actually will make a new mesh feature, because everything in this mesh feature just includes the basic construction. And now I will make a new mesh feature that will include all the fine details. So let's see at what level I have to do it. Yeah, I will do it here. All these arrays, that's what we will do after also these wood parts have the holes cut. So create base feature and insert mesh, and where are the wooden dowels? There. And cancel. I was wrong, sorry. I said base feature. That's not true. Sorry. In this case, no, we have to go with the create form. So form, and that is the T-spline module, which is very much similar to modeling in Blender. Okay, that's good. So also here, insert mesh, there, open meters. You see they snap into position. Okay, and then where do you have it? Convert. Yeah. So convert this mesh. So this body. Click OK. And what does it say? 30 quads, triangles, polygons, there are some n-gons. So it's a little bit cranky, and that's probably because I kept the faces. Okay. In case something like this happens, there's one simple thing we can do. We can go to here and say Y. So this face I select, and with Y I rip it off. So I disconnect it. So you see I can move it. But I only rip it off, but I leave it where it is. So with those four selected again, because they're all linked, they have exactly the same geometry. Let's export this one more time. And same name. Good. Let's go to Fusion. And then let's finish form. This one I remove. Okay. Insert mesh. Dowel there. Okay. Meters. Okay. Convert this one. Come on. Select. There. Okay. It still gives this result. And that's kind of silly. Shouldn't really be. Okay, so what could we do in contrast? Let me double check something. So not that I made a mistake. So I will just export this one more time, but just with a different name. I just want to double check, not that I overlook something. So let's delete this. Insert there, open. Okay, and then convert. Yeah. Okay, good. So this is actually a little bit new. That worked in the past, not a big deal. This sometimes happens also in my lectures when something breaks, and I keep this stuff on purpose in my videos, because if I only show you when everything works, I never show you when something fails and how I will solve it. So I know, unfortunately, this sometimes might mean there's a little bit of listening to do, but on the other side later, the advantage is, well, you see how I would fix it, and then later you know how to do it yourself. Okay, perfect. So you see I moved actually this part out. See there, it's open. So these are now basic tubes. Export. Okay. And create feature, don't show this again, insert mesh, there, meter, okay, convert this one, okay, and there, no complaints. Let's take a look, and you see beautiful, nearly somewhat rectangular parts. Okay, let's finish form, and there you now see there is a perfect NURBS surface. So I took actually that geometry, and which was polygon based, and then we converted it into the T-spline sub-D-like environment, and then that actually later was converted into perfect NURBS geometry. Okay, so there's one little step left. You see these parts are open, so we can actually in patch mode go to create and say patch, right click, patch, right click, patch, right click, patch, and then we go to the other side. There. Okay, perfect. Good. So join, and everything there should join. It did. Join. So you see I actually do the drag from right to left, and it selects through the object only the faces, and there are now all my individual dowels. Perfect. Just as a note, so combine U 1, 2, 3, 4, keep, and there are my holes. See? Perfect. And we can, for example, do the same one more time to this. 1, 2, 3, 4, and keep the tools. Perfect. Because we want to later trim actually the individual dowels off, so we use actually the cylinder to cut the holes, and then we actually use the faces of a wood plank to cut the dowels, so we maintain actually what's inside. So let's do this. Split body, 1, 2, 3, 4, split by this outer face. Curious, can we split by this interface? Oh, we only can do it once. Okay, that's fine. Ta-da! And again, 1, 2, 3, 4, split there, done. Perfect. And 1, 2, 3, 4, 5, 6, 7, 8. Not you. And then all those I would like to remove. So and remove. Ah, shoot. I didn't really select them in the order I wanted them. Hold on one second. Where did this remove go to? So sometimes this was inside. That's not what I want. So you have to be careful which one you select in the browser. One is, so this is outside, this is inside, outside, 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 yep, yep, yep. And these are the insides. Okay, all those remove. There, see? Now then, there we have the part with the dowels, and also we have the holes cut. So you see pretty much the same process. And that's the reason why I did this actually after the mirror command. You can see then the mirror command moved this stuff over. Sorry, I did this in front of the mirror, not after. Double click the mirror command, the objects to mirror, and then I hold the Apple key on the Mac, I think Control on the PC, or Alt, you have to see, and then I add those to the selection, click OK, and now also my dowels got moved over. Perfect. Okay. So how do I do now everything with the wood planks? Well, basically I need 1, 2, and 3 dowels. Then I can do the cut it into it. I also have to mirror the dowel over to the other side, but there I think we can use the feature for it. And then with the array, the results, and for the dowels, we move down. Okay, so let me show you how this works with one, and then you're basically nearly set to finish the design completely yourself. Okay, so let's go back to Blender, and before I continue, there's actually one thing I wanted to point out. So you see I moved these caps out, and this was a workaround basically for Fusion. Obviously I might actually want those to be still in place. So let me double check something. I want to make sure if this actually still works. Okay, so that actually worked. How are my dowel parts here? This is the other dowel. See, this geometry we didn't even need to bring over for the dowels because we recycled the parts that do the cutting in Fusion, and after we did the cutting we turned them into the individual wood dowels. So we're good. We can keep everything the way how it is. Only this one, and this one I would like to adjust a little bit, and here we have to prepare this a little bit differently. So Shift D, I made a copy, M, and maybe I put this for the moment to layer 0. And where are the parts I used before? There. And where is that sub D dowel? Shift D, escape, M, and 0. So everything I have here on one layer. So why did I do this? Well, I have to adjust some of the dimensions here and the geometry, because here as well I have this whole part. I could also, if I want to be a little bit lazy, simply remove here these caps and then bring it over. But the main problem is, because there are a lot of points, T-splines will have a lot more to do to recreate that circle, which is why I created this very coarse geometry, which later, when being smoothed, will give me the same cylindrical look. So Shift S, cursor to select it, and then selection to cursor. Perfect. Then I would like to rotate this one correctly. You see this is 90. This is X there and 90, and that's definitely not correct. So what's going on here? So what's happening is simply that this object is not rotated while this one is rotated, but it's not 90 rotated. So actually what's going on is, don't forget, these are linked to your parent. It's actually a good situation to maybe tell you what happens when I unparent it. So I just made a copy. I can press Alt P or go to parent and say clear parent. Bing, it's there. See, 90 degrees rotated. But it also jumped to somewhere else. But I would like this one now to be unparented. but maintain its position. So we can go to Object and then Unparent and say clear and keep transformation. And you see 110.5. So this one 110.5, there we are. Actually, hold on, this one we simply reparent, so I undid this because I only needed to know the value. Okay, perfect. Now what I can do is the end, I move back and then I snap to there, and here I bring this one down and snap to there. Okay, perfect. So Alt D, make a copy, and then I could say U to U, U to U, copy selection, and yikes, there's the same again because this is rotated. So cursor to selected, selection to cursor, rotate 90, there. Goody. Alt D, and there's this one, cursor to selected, selection to cursor, R minus 90, and then we rotate this one, I think R15, there. Or in case again there this is too confusing, we can simply Alt P, clear parent, then we know the value, copy it, undo the parenting, and then we can paste that value in. Perfect. Goody. So basically with these parts done, all this we can delete. We don't need it anymore. And also this one we can delete. So these are only the dowels which we need. Select them, export, no modifiers. Let's say dowel rest. Go to there. And see, this is getting a little bit long. So left mouse button click, shift left mouse button click, right mouse button click, make a group, and we cleaned up the timeline. And here now we will create maybe a new form and then insert and wooden dowel rest, meter, okay, convert this object, so you have to select mesh body, okay, finish form, and all those for the moment we can hide. And then unfortunately we have to do the patch stuff here again. Patch. Well, you see it's not too much, it's just calling that command 9 times. Okay, good. And then once this is done, stitch and stitch and stitch. Perfect. Now we can, for the moment we can hide those and show those. Okay, great. So now we have actually the dowels positioned, and I will finish everything just with the front plank and then show you how we finish the bottom parts, and then the other 2 planks you know how to do yourself. So it's now advisable to go back to model and say combine U minus U and keep the tool. So now we cut actually that hole into the wood plank. combine U minus U. Okay. Combine U, the other part, minus U. So we have both holds. Now you see it left and right. Okay. Perfect. And the wooden dolls, as you can see, they stick out a little bit. So we could say split body U, U split by U. That's one possibility we could do. We could, because now this is timeline based, at the end also select maybe, let's see, I would like to select this face. Can we extrude it? It doesn't allow us. Okay, good. Never mind what I wanted to say. We go back to the split body there. I did the same thing. You split via this face, cut, and it's gone, and then there, this one we remove. Okay, great. This is pretty awesome. We're nearly done. So we have actually here the whole cut, not there. So which command does the cutting? This one. So now I would like to mirror this over. So I moved my time marker, for example, to there. Then I can go to mirror and say feature this cut along this mirror over. And that's interesting. Okay, I might have to send something to Fusion because this actually has to work. I don't understand why it actually does not work. This really should work. That's the process. So feature U across this plane, because you can see it actually highlighted there. Okay, it doesn't do it. So, okay, bugs happen. Well, how can we fix this? Well, we basically made a cut into the object by using the dowel. But if we go before we do the cut, then actually select object, select the dowel, then say mirror it over. Okay, you see there it is. And then we go back to the Boolean cut and say, hey, this feature, just select this as a secondary target. Yeah, keep it and cut. Perfect. And there we are. And then this is actually a duplicate. In this case, we can, I think, remove it. Yeah. Okay. So, for example, I move this to there. And to be a little bit more precise, can I move this one to there? No, it doesn't want to. No, we can keep it there. Okay. I'm curious if I... Nope. Good. Okay, great. So now the question is, well, I need to get all the wooden dowels actually also down along this area, and I need to do the cuts. So the nice thing with the wood planks, I don't have to do the wood planks anymore, because you see this masterpiece is done, and then the array tool makes the copies for me. But how do I now do the rest of all the dreaded cuts? I was actually curious. Can we select a whole actually? No, I was just curious. Okay, that's another way how you learn a lot. You just try to, does this maybe work? So, and let's go back to here. Then this one I would like to turn off because we have this element left. And I need to array all those down. So we can go to pattern array. We select this as a direction and move this one down. And I think we have 4, and then one, what was it? Array spacer. Nope. Okay, let's take a look at it. Oh, spacing. Let's say array D. That's so much easier to memorize. And there, this direction, down, array D, 4. Okay, now let's see if this fits. And it does. So because the array modifier here uses like specific distances, at each distance point it just centers the new geometry. Okay, great. The mirror modifier, by the way, I want to move at the end. Why did I want to move this one at the end? Well, because I created all these dowels, but I don't have the holes in there yet. So after this, Boolean cut, ding, 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 or which one is which one now? I have to see which cuts into which side. I can actually add this. So these 2 commands I actually remove. So I clean up my timeline so it's a little bit more logical. So it also shows you with this, in case you make a mistake, how can you fix it. So I want it to be a little bit more organized. So I have this dowel, and then we did geometry with it, we cut it, and then you see now there we, for example, trimmed the top part off. Okay, and then we made this nice array. Perfect. And after this array, now, for example, it makes sense to say u minus u, keep the tool. Okay, one more, u now minus 1, 2, 3, 4. I was actually curious, can we select an array? Nope. Okay, we have to select the objects there and keep the tools. Okay, so you see it's a little bit more logical because the timeline is like how you structure your designs. And the reason why I put the mirror command at the end is you see it mirrored over the result. Perfect. So mirror command added, because I would like to add those dowels. Okay. And I would say the front part is finished. Where's this one lag? I don't have it. Edit. No, I do not. Okay, you as well. Get over. Perfect. Okay, so that's basically it in a nutshell. There are 2 commands at the end. When you're done, you want to finish. So, for example, I would like to split and trim the bottom off, for example, this one and this one. Ideally, again, we want to do this in front of the mirror command, so that one's always the poor little body at the end in our case. So split tool, the splitting tool in this case is actually our plane. So this is actually y and x there. Click OK. and then this one and this one we remove, mirror it over, and there you see now that stuff got rounded, got cut. And if we want to apply nice round fillets, for example, again, we do all the stuff before we do the mirror, so it saves actually a lot of work. Then, and we might actually even want to do all this before we even start all the cutting of the other elements. So just to show you where the fillet is, there's the fillet command. And then we can, in our case, let's say zip, drag everything over. But there are all the holes cut. This is not what I want. Okay. And we have to be a little bit more selective. So maybe this edge and this edge, this edge, this, and this edge. So you see it's a little bit more tricky. So we want to work on an individual object basis. So in this case, height, no, not hole, height V and V. So I see all this. This is better now. Now I can go ahead and say fillet 1, 2, 3, 4, 5, 6, 7. Add all those with a swipe. And maybe, let's say, 0.5 millimeter, just with some sandpaper or so, we just break the edge, or with a millimeter to make it a little bit rounder. Okay. Then we can show the other objects. So for example, this one we hide pressing H from Blender, but it's a V in Fusion. So for example, you and you, you and you, again 0.5, or this is now, can actually see which parameter this is, fillet. So rounding, and rounding, whoops, spell it correctly. Okay, there. And then we have this one here, we can do the same. Can actually, hold on, let me show you something in addition. So V, 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 and then so much vendetta, ding, 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 ding. Okay, so they're all hidden. And this one here as well. Edit. And I will actually, in addition, shift and select all the edges of this as well. So this feature rounds all those wood planks there. Now I need to figure out where is my other part. There, I can hide all this there, and fillet there. I do not want to fillet the roundings, so careful that you do not select those. Okay, that's good. And this was rounding. By the way, you see there's a pull down menu. It gives you common used or common options and something you entered before, so rounding, so I don't have to type it all the time. Perfect. Let's go back. And there you see that's the reason why I wanted to put the fillets right at the beginning, so that after the mirror command I have basically the other sides also mirrored over without having to fillet all these individual planks as well. And again, you see, I hope at this point, the similarity between the way how I teach in Blender and how I work in Fusion, basically the way how I work in Blender is informed, by the way, how you have to work in Fusion, with the advantage then that this way you have a common workflow that is makes it possible for you to bring your Blender data seamlessly without much problem over into Fusion. Now this video took a little bit longer because I needed to explain everything, so you might have the impression, whew, this was still a lot of work. Well, design is a lot of work, but you have to ask yourself if you can explore conceptually an idea somewhere faster, doesn't that then sacrifice, or doesn't it okay that maybe, like in this case, we have to spend a little bit time on prepping the geometry and the data? And because I explained everything, this also took longer. Once you know how to do it, it will be much, much faster. Trust me.